So to begin this conversation in these examples, we're going to revisit an idea called the sample proportion, and then we'll get to it's called the distribution of the sample proportion. So we're at 8.2, and so the first thing we need to recall is the definition for sample proportion. Sample proportion, we use the p hat. Sample proportion, what is that again? So we use that symbol p hat to do that. It's again, X is the number of individuals in the sample with that characteristic. We ask them a question, and then we find what percentage of people match that characteristic. And many times this is what we call a binary choice. Is chocolate your favorite ice cream? Yes or no? And you can find the proportion of people. So the sample proportion is a statistic that estimates the population proportion. Again, we're always interested in statistics to find out what is the sample proportion statistic, right? And the most important thing here is that that statistic estimates the population proportion. We want to know what's going on with the population. And so in those cases, we don't have access to the population. So what we do is we conduct a sample. In an instance like this, survey 1,200 adults who vacation during the summer, asked whether individuals plan to work while on summer vacation. 552 said they plan to work out of the 1,200. And then from there, that's 0.46. So we know 46% of people plan to work. And again, we only asked 1,200 adults, but again, that's supposed to be an estimate of the population. And so that's the idea again we had done before, and now we're talking about a sample proportion. This leads us to our next idea, similar to chapter 8.1. In 8.1, we did sampling distributions of the sample mean. In this section, we're doing sampling distributions of the sample proportion. So we're going to use a simulation to kind of explain that. So you have some pictures there in your note sheets, but let me show you a couple more. And so here's a sample question. According to a time poll conducted in 2008, 42% of voters believe that gay and lesbian couples should be allowed to marry. So that's 2008. Describe the sampling distribution of the sample proportion for samples of size equals 10, 50, and 100. So what we want to do, here's this word again. We'll define it in the next page, but here's this word, sampling distribution, right? And so what we're going to do is we're going to sample multiple times and then look at the distribution of those results after we sample. So not just sample once, but we're going to sample many times. And when we sample, we're going to sample 10 people. And then what would happen if we sample 50 people and 100 people? We did that multiple times. And so what it looks like here is that if you ask 10 people, so what this picture here is, this is basically asking 10 people in this case, right? Not asking 10 people. Let's do this again. Yeah, asking 10 people 300 times. 10 people 300 times. What would that look like? The same question. Do you believe gay and lesbian couples should be allowed to marry? Here is a sample distribution of those 300 samples of size 10. We know the answer is 42, the population. And so you can see the distribution. When you ask those 300 different samples, you can see you get a wide variety of answers. You're asking 10 people 300 times, almost like 100% in one case, but again, mostly people around the middle. What would that look like? And you can see that the mean, we would calculate the mean and standard deviation of those samples or the distribution. And then what would it look like if we increase the sample size? Ask 50 people 300 times, 50 different people 300 times, notice it gets a lot closer together. They're getting closer to the mean when we increase the sample size. Mean is 0.42, standard deviation 0.072, getting a lot closer. Remember the original was 42%. And then what happens here is when we ask 100 people 300 times, it gets even closer together, and the mean is 0.42 and 0.047. So again, that allows us to estimate the population just by doing samples. Even just of 100, we get really close to the population, or the mean equals the population, and the standard deviation is 0.047. It gets closer and closer, right? So we're getting like narrowing into the correct answer. And so that's what we're talking about here when we look at, if you go back to your note sheets here, that's what we're kind of looking at, those distributions. As you ask 100 people, it gets really close together to the answer, what the answer is. And so just doing multiple samples and looking at the distribution of those samples gives us a very good estimate, right? So a takeaway that you should be thinking about, sampling distributions give accurate estimates accurate estimates of the accurate estimates for the population proportion. For the population proportion. And we'll see that on our next kind of part 2 of this, what I mean by that. Sampling distributions actually of the proportion. So proportion, give accurate estimates for the population proportion.